Turn this light off? Okay. All right. The reason I like this is actually, I could have just said 8-1, day one. It's going to be real easy math. But I actually learned something. And I like to share that with you because I've taught math for 20, I don't even know right now. I think it's 22, 23. But then in actually reading this section, even though I know I've taken stats, I never knew this. And actually I found it pretty powerful. And then I could add my little Samulus to this, like what this means, what I'm reading, and what I see about these two guys that have everything to do with what this section in this chapter is all about. One is William Playfair. Look when he was born, 1759 to 1823. And then this John Tukey guy, 1915 to 2000. Two completely different people. And you'll find at the end of this, these are the two people and only two people that really invented what we're actually going to study in this section. All right? And what Playfair did, and here's what I told my students last year, I guess last semester. When I'm directing, I should say, as a better teacher, I should say, go ahead and read this right now, class, and then make them read it, and then what are your feelings about this? Whatever, all right? I've blabbered enough this whole section. I'll highlight the points, and then if you go back and reread this, you'll get more power out of it than what I'm highlighting here. But this William guy lived during a great time of revolution. Oh, I love revolution. I'd like to have one. Never mind, I don't want to get into that. In ideas and governments, both in Europe and America. He saw the value of persuading the common people instead of the aristocracy, which is the higher-ups. And believe me, there is an aristocracy in this democracy. There are people that are in charge that dictate what we do in our lives. It is a true statement no matter what the government is that we have. There are people with power that dictate what happens in your lives. So that is why the common people sometimes need to be informed and understand things. And that's why I like, and what I got out of this reading, what this guy did back in this time of revolution. He discovered that a chart with a good visual design provided more information and had more impact than calculations and tables and numbers thrown on a piece of paper. So most people can look at a picture and get more out of it than a listing of numbers and written ideas. So he found a way to graph this data in order to exaggerate, and I love that word, exaggerate a point. Oh, what the heck is that? I don't even know what's going on. So out of practice. Exaggerate the point that he was trying to make, so he could sway people more easily. Now, it does come across as maybe a little deceptive, but he wanted people to understand it and wanted to make an impact. So his most famous graph, which showed prices of wheat versus a rise in wages, was actually misleading. But he applied insights from humanities, mathematics, engineering, and geography when constructing his charts. His work was so effective that it soon permeated all forms of communication. Now, this is what I found interesting, and we see this all the time. Anyone watch the news? Big news people? Okay. One. Great. Communication, quantitative information, books, newspapers, magazines, and televisions present a wide variety of visuals to inform, impress, and persuade. How many people are interested in politics? Oh, you say Trump, some people want to kill me. All right? You say, what was the other person that lost? Clinton. That makes other people mad. Okay, but do you understand how much persuasion there was on both sides to get your vote, and how powerful it was to give graphs or show images and make one person look bad or the other person look good? So I thought about all of that when I was reading this. Few people realize that bar graphs, line graphs, and pie charts are the result of one person's genius. So the ability to sway people by an image, from math numbers to make it an image that is more powerful for someone to understand, is this guy and this guy alone that started it off. And I never knew that. Then to go to this guy, he is the second guy that does what the things we're going to do with. And if you want to read this yourself, that's fine, but he was the one that did stem and leaf plots and box and whisker plots, so on and so on and so forth. I found this interesting, even though it's not what we're doing, but we did this last semester, or at least talked about it. He termed the word bit, which is binary digit, which is what's used to deal with computers, and termed the word software for the first time. So you got a lot of these interesting characters that have, they're the reasons for some of the things that we have right now. And I tried to do that throughout the year last year to get you to understand that. So nearly all of the graphs and charts that we commonly use to communicate and analyze are because of these two people and these two people alone. Never knew that, never once, even though I actually took a full stats class. Found that amazingly intriguing. Okay, and then one last thing. This is reverse. This is the previous page, the start of the chapter. And I found this kind of funny that it talks about a realistic situation where the state budget was, according to one person, growing completely out of control. So this person, according to this reading of a real world situation, sent out a flyer to the common people. And take a guess, even though these two charts are both identical, which chart did he send out? The one on the left or the one on the right? Which one looks more exaggerated? Like the difference between the budgets, the one on the left or the one on the right? The one on the left, because look at this. This bar is very, very small compared to this bar that's very, very big. But notice the difference between the two charts. This one, the first line starts at what? 6 billion. Whereas this line starts at what? 0 billion. So these are the exact same charts showing the exact same difference between the two, or the years and the budgets, but this one looks like a much more exaggerated difference than this one. And there you go. The use of the image that you use can make a different impact on people just by what they see. And that's kind of like encapsulates everything that I started this whole shindig off with. Okay, blah, 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 blah. Thanks for the history lesson, Mr. S. I thought this was math. Though we know last year it barely was math, right? We did some numbers. Okay, so all that, blah, 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 blah. Basic statistics is taking numbers you observe and organizing it in some way, shape, or form so we can make sense out of it, maybe make some extrapolations. Just analyze the data. So we're going to start with 8.1, methods of organizing and picturing data, and we're going to take it real slow. So really today's assignment's super Mickey Mouse. So before you can organize and picture data, you got to collect it. And one of the ways they say, not that I wrote here, you could look it up. You know, there's the internet now. I don't know if you heard about that. And you can look up just about anything as far as data is concerned if you just typed it in Google. And then you can take that data and do what we would do here. Or, number one, you can run an experiment. An experiment is more objective, I guess you would say, than observational study, which is the second thing I wrote there. Because in an experiment, you control the variables in some way, shape, or form. The thing in the book, I did read it, try to think out loud. They talk about doing a drug test, and they not what you're thinking. They like a drug that might help somebody for a disease, and they give this amount of subjects the drug, and then the other a placebo. You ever heard of placebo, right? And they see if there's a difference between the two situations. You know, does the new drug actually make a change in those compared to the ones that have a placebo? So that's like a controlling of variables. So I put off to the side, I stole this off the internet again, just to make sure you understood what objective and subjective means. Objective perspective is one that is not influenced by emotions, opinions, or personal feelings. It's based on fact and things that are quantifiable and measurable. Thought that was a good, powerful statement to understand that. Pause. Okay, then observational study is more subjective. Let's look at that word. That's is one that's open to greater interpretation based on personal feeling, emotions, and aesthetics. Just a definition I stole off the internet. Sounds good to me. That means observational study is someone just sitting there and looking at something. Then they write down their perspective of what they're seeing. So, natural environment, researcher records relevant data, and it could be a little bit more subjective than actually doing an experiment. Last way you could collect data, not the last way, just another way, let's say, is doing a survey, which we all know about. As you're writing this down, if you want to take notes verbatim, that's fine. Not necessarily a survey, but I was surprised first hour. Maybe they just didn't want to talk to me. Anyone ever hear the Nielsen ratings? I think that's still a thing. No one knows what the Nielsen ratings are. Maybe it's changed a little bit, but the Nielsen ratings are how we weekly, I do that too, weekly see what TV show is the best TV show most watched. Now, do you think they have every TV monitored to see what happens there? No, what they do, and I thought about this, is a sample population. The actual people that run this Nielsen thing, they actually get demographic population, and they get X amount of each kind of demographic. And I also say this: rich, poor, live in this area, blah, 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 blah. And they try to get a selection that represents the whole population in the United States. So the Nielsen ratings are not perfect, but scientifically they believe through getting the people that they have, it does roughly represent what happens in the country. So it is, that's what a sample population example might be for that. But anyway, for a survey, a little different, using a questionnaire or interview. It's convenient. Sample from a population of interest. I think it could be costly, but in this case, maybe they're saying it's less costly. It depends, I think, really. Okay, so of those three things, we're going to do a data analysis. It's going to be real Mickey Mouse today. So exploratory data analysis, it's an initial look at the data to see if any patterns emerge. That's why we do what we do. See if patterns emerge so we can make some sort of presumption now and maybe make a prediction later what's going to happen. So what we need to do is look at these numbers or data and put it in some sort of checkmark visual representation. Now, we're certainly not going to do all of these today. We're only doing and looking at the very first two, which are very basic and simple. Really getting a simple representation of statistics to start off, and as we go, we'll see how in depth we get. One simple way is just do a simple dot plot. You'll be asked to know how to do that. A stem and leaf plot, very simple, and they're very similar. Just a different way of doing the same thing. Move on, in later days we'll do a bar graph, which represents both a histogram and a relative frequency histogram. Line graph, I'm sure we know what a pie chart is. And has anyone done a box and whisker plot? We used to do it in this class called Algebra 2. Doesn't exist anymore in Lockport. Who was in Algebra 2? Crushed. It's been destroyed. We used to do it, I don't know, if maybe not anymore. I know back in the day when I taught Algebra 2 here, we did box and whiskers. So we'll do it here, and you'll just get to see what it is. And somewhat interesting. Actually, the graphing calculator does do it, but I don't know if we'll waste time on looking at that. It'll be me. Okay. So the first thing we'll do is a dot plot. Just bear with me. If you weren't paying attention at all up to this point, pay attention now. So, synopsis, you get data. We want to put it in a graph so we can analyze it. This is the most Mickey Mouse way you could do it. So here we go. Oh, I didn't realize that. Stats test scores. Cool. So these are test scores. 6? Get out now. Okay. All right, but 53, 82, okay, 76, 78, 94, all right. This actually is kind of realistic to how August started. All right, so these are test scores, and I do analyze that data sometimes, and that's, I basically just look at a 6 and see it, but what if there was like a lot of 40s and 50s, and no 90s, then maybe the test was not necessarily fair. So one thing you do is do a simple dot plot, and if you're writing those things up here, this is just what it is. You do a horizontal axis, which represents the data. So it goes from 6 to 97, and knowing a test you could get 100 on, and you could get a 0. So your horizontal axis is 0 to 100. And all I ask you to do is be neat and make these equally spaced. I don't like, no one likes messy, non-equal spaces. It doesn't look good. And then the vertical axis is just the frequency, which I don't know if that word came up there before. I forgot to say. Frequency is just how many times a particular score happens. And it doesn't necessarily have to follow, like 1, 2, 3, 4, 5, 6, because you can look. Well, it does kind of follow there. There were 4 76s. So I would expect above 76s 4 dots, representing that 4 people got the same grade. And then 82? 2 people got the same grade. And this is how I would do it too. I'd draw this. Maybe draw this vertical axis to be at least up to 4 because I see 4 grades. And then I'd write 53. Then I'd write 6. But I make sure I cross them off as I go so I don't repeat any numbers, so I don't make a mistake. Make sense? All right, and then you can look at this and say, is this a fair test or not? Well, it really depends, but I really kind of feel it's fair because there are a couple 3As and quite a few people, hitting that middle B and middle and high C range. And it really depends on the class. I've been teaching for a long time. You do get those classes sometimes that there are a lot of people that don't do what they're supposed to be doing. Or what if they were and it's just a little bit rough? Then I might have to talk to these people and say, all right, you are trying, maybe try a couple different things. Or you better make a decision to try harder because you aren't, so on and so on and so forth. So this data can be analyzed where, would I say this is a fair test or not? I actually would say it was, and I bet you these 4 people could actually do something. And then this one person probably should go. All right, this is not the class for them. True story, just being honest. You okay back there? Okay. Clusters. Oh, it's not really, is that a word? Is that a term I have to know? No, you can kind of see some scores are clustered from the 70s to the 90s up to 100. There's a little cluster from 40 to 60. We have to look at those people. And then there's definitely, you know what this is called? It starts with an O. OU. That's an outlier, man. That's an outlier you usually get out of the data. An outlier can also be good. Say one person got 100, then the next highest grade is a 70, then the next highest grade is a 68. Well, there also could be a positive outlier where, all right, that student should probably maybe be in a more difficult class, and I really should think about the test, not including that person. Was it fair or not to the rest? Not fair, but, do we have to go back and look at some material, which we don't have a lot of time for a lot of times. But so stem and leaf plot, don't write any of this down. I bet you can figure it out. Look at the numbers up there. Hopefully you can keep your notes together and then understand what a stem and leaf plot is, which is almost exactly like the graph, except it's not a graph. So you do it vertical, and what these numbers on the left in red are the tens place. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then if there was 100, I'd put a 0 here. But there wasn't 100. The highest grade was a 90 what? 97. Then 94. And then that's how you do a stem plot here, because then you could actually see the clusters just as easily. So it's really a different way of doing the same thing. See where the grouping is, make an analysis of the data so you can analyze what the test was compared to the class. So you get it? You understand that? Okay, because then I could reverse this and then give you the words, which is exactly what we just did there. Draw a vertical line on the left. Those are the multiples of 10. On the right, the leaves are the 1 digit. So this represents 97, 94, 82, 82, 89. There's the 3 76s that we talked about. There's the 2 82s, so on and so on and so forth. So we're just Mickey Mousing it to start off. This is how a couple ways of organizing data.